So students, clear what is the meaning of drying exactly? Then whatever the terminologies we have written over here, what is the meaning of bound water and unbound water? So as you know, drying is a process in which the liquid or maybe the water component present in a wet solid is removed by application of heat, and finally a liquid free solid product is obtained, that is called as a drying. Outcome is what? Liquid free product. Clear? This is a simple definition of drying, and we have taken or considered analogy over here. Whenever you are dropping your clothes in washing machine, and after rinsing, after drying, still some water component is associated with clothes, and at that time you keep that clothes in your balcony or maybe the gallery or maybe on a terrace, and because of the sun heat, whatever the water part is there, that gets evaporate and your clothes become completely free, and that is called as a liquid free product. So students, then what is the meaning of this bound water as well as unbound water according to you? So you can easily talk about bound water composition. Yes, please.
So bound water is the moisture that is absorbed on the surfaces and it exerts full pressure.
Yes, Nikita. Bound water, it is the moisture contained of a substance that exerts a equilibrium vapor pressure lower than that of the pure liquid at a same temperature. That is called as a bound water. And when you compare bound with unbound, so unbound is what? It is also the moisture content of a substance that exerts a equilibrium vapor pressure equal to that of the pure liquid at a same temperature. So just for our understanding purpose, I am just mentioning here bound water and unbound water. So whatever the vapor pressure is there, when we are talking about the concept as a bound water, whatever moisture present in a substance, that certainly exerts some vapor pressure, and that is lower than that of the pure liquid. And in case of unbound water, suppose if you are talking define unbound water, such kind of definition will come for 1 mark. So what will be your expected answer? It is the moisture contained of a substance that exerts a equilibrium vapor pressure equal to that of the pure liquid at the same temperature. So I just copy the same thing over here, but I am mentioning over here not lower than, I am mentioning over here equal to your liquid. So that is called as a unbound water, and obviously this reaction will be carry out, or maybe the definition will considered at a same temperature. I am also mentioning over here as a same temperature, and obviously one more keyword we will add over here as a moisture content. Clear now definition, bound water and unbound water? Any doubt over here? Because these terminologies we are using to understand the various equipments that we are using for drying purpose. Whereas free moisture, what is the meaning? of free moisture. It is the moisture content of the solid in excess of the equilibrium moisture content. That is called as a free moisture. Clear this particular thing? Free moisture. It is the moisture content of the solid in excess of the equilibrium moisture content. That is called as a free moisture. Then obviously question will pop up in your mind, then what is a moisture content? So moisture content is what? It is measured by a ratio of wet of dry sample to the ratio of wet of water in a sample. So this is nothing but the ratio, isn't it? I'm just mentioning over here as definition of moisture content, that is the wet of dry sample to the ratio of weight of water in a sample. So that is called as a moisture content. Clear this definition as well. Any doubt over here, you can raise your hand, or maybe you can share your thoughts over here on various terminologies, whatever we are going to use. One important definition is there, students, equilibrium moisture content. What is an EMC? Equilibrium moisture content, it is the moisture content of the solid when in equilibrium with the given partial pressure of a vapor in the gas phase, and that is called as a equilibrium moisture content. Clear this, because this definition is also important over here. So what we are mentioning over here, it is the moisture content of what? Solid only. And what is the difference? When in equilibrium with the given partial vapor pressure in the gas phase. I'm just writing keywords over here. Clear this particular definition, equilibrium moisture content. That is the moisture present in a solid only. But when in an equilibrium with the given vapor pressure in the gas phase, that is called as a equilibrium moisture content. And this terminology is very useful to understand the drying curve. One more important terminology that will pick up as a critical moisture content, or a CMC. So what is the meaning of critical moisture content? The point at which decrease in drying rate start. That is called as a critical moisture content. Point, isn't it? That particular point that we will consider at which decrease in drying rate starts. That is called as a critical moisture content. Couple of more terminologies are there. That is fluidized state. What is the meaning of fluidized content, or maybe the fluidized state of a molecule or a compound? Fluidized state. We can easily mention it is the state in which the granules are suspended in the airstream and rise from the bottom. That is called as a fluidized state. And this terminology that we are using when we are talking about working of fluidized bed dryer. So fluidized state, it is a state in which the granules are suspended in the airstream. So that is called as a fluidized state. So I am just mentioning over here granules. These are suspended in a airstream. That is called as a fluidized state. Then one more terminology that we are going to cover in a drying curve or pattern of a drying curve, or I think you have some couple of experiments also on these drying experiments, and I think you are covering same as a part of practical. So you can easily correlate with all these terminologies in a theoretical point of view as well as practical aspect. So desorption is one more terminology. So anyone would like to add over here what is the meaning of desorption and sorption? Any student would like to add anything over here on these two terminologies? What is your understanding about desorption and sorption? Akshat, you can talk, or maybe Anish, you can share your thoughts on these two terminologies, or Devanshi, you can also drop your points over here. And one more students I would like to ask Jenny as well, Jenny Thakkar, to
Yes, sir.
mention about this desorption and sorption. Can you give any input on these two terminologies or what is your understanding?
Sir, sorption is basically absorption or adsorption.
Okay, okay, Anish, agree. Any other sharing?
And sir, desorption उसका उल्टा होगा ना? Release of the sorption वाला substance.
Correct, correct, correct. Yes, whatever Anish reflected on this particular two terminologies, the same point we will pick up over here by considering your understanding related to equilibrium moisture content, this particular terminology. So that is the same, that is moisture content in a solid when in equilibrium with the given vapor pressure in the gas phase, or maybe the to understand the drying curve pattern. So by considering this understanding at your end, we will pick up this terminology and try to understand what is a desorption. So desorption, if solid contains more moisture than EMC, isn't it? More moisture content than EMC, or maybe I will just use greater than symbol. More moisture than the equilibrium moisture content, then solid will continuously lose the water. क्या होगा फिर? Obviously water composition ज़्यादा रहेगा, तो डिसॉर्प्शन में क्या होगा? That will release the water continuously. Till what time? Till this equilibrium moisture content point gets achieved. Till that time the water gets released, and that is called as a desorption.
Excuse me,
Clear this
sir.
terminology? Yes.
Sir, sorry to interrupt in between, but I'm facing some network issue. I just got some stable net. So I wanted to ask if it is possible, can you share this PPT or this thing after the lecture so I can go through with all the stuff
Sure, sure, sure.
and also the notes of the previous if it's possible, sir.
Yes, yes, yes. In previous session only I cleared na whatever the content is there. So that soft copy of book, whatever the Notes material is available that I will text you in your inbox.
Okay, sir. Sir, can you please save these things, like save this document and send us?
Yes, yes,
Please,
that I
sir,
will.
do it today itself, na?
Yes,
So
yes,
we can study tomorrow.
yes, 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 sure. So in case of desorption, as we are talking about more moisture, more than the equilibrium moisture content, at the time the water gets released from the compound till gets EMC point again. And exactly opposite to that sorption, if solid contains less moisture than the EMC, as Anish told, exactly opposite to the desorption. Suppose I am copying this particular two things over here, dropping over here, instead of this symbol, I am using less than. So more moisture, whatever the composition is there, or this is the moisture I am talking about, moisture is less than the equilibrium moisture content. That is a solid that contains less moisture, isn't it? So here maybe I will add less moisture word over here than the equilibrium moisture content. So that is called as a sorption. And obviously solid will continuously क्या होगा फिर यहाँ पे release. Here what will happen then? Here solid will continuously absorb water till it reaches to the EMC, equilibrium moisture content. Clear this thing, students, desorption and sorption. I am giving you more trace over here. I am taking these terminologies very slowly over here because same kind of the terminologies we are using number of times when we are talking about principal construction working of various equipments in this particular drawing chapter. One more last terminology we will pick up, that is about isothermal desorption. So isothermal desorption you know now. Now isothermal, only one word we have added just before the desorption. So it is the process of reducing the residual moisture content to optimum values when drying is continued at warm temperature, isn't it? So drying is at warm temperature. Same thing, more moisture content than the equilibrium moisture content. At that time it releases the water continuously to get this particular point. But when we are talking about isothermal word over here, so drying is at warm temperature, we are using the terminology as a warm temperature. So clear this particular point, whatever the terminologies, drying, bound water,
Yes, sir.
unbound water, free moisture, moisture content, equilibrium moisture content, critical moisture content, fluidized state, desorption, sorption, and isothermal desorption. So moving further, by considering some basic points, we will talk about now. In previous class, we have discussed about the differentiation between drying and evaporation, isn't it? And you only pointed out some points related to what is the difference between drying and evaporation. So obviously, water is removed at the temperature below the boiling point of water in a drying, and in evaporation, water vapor is removed at its boiling point. Also, small amount of water removed from the solid in a drying, whereas in evaporation it includes removal of large amount of water. And yes, dry solid product is obtained in a drying, and in evaporation final product is either concentrated solution, suspension, or slurry. That is not expected that complete solid product you are getting in evaporation. And obviously in drying, carrier gases such as air is used to remove the water, and in evaporation no specific gas is used, isn't it? So in this way we have just recapitulated the difference between drying and evaporation as well. And dear students, always question will be there for 2 marks, difference between drying and evaporation. So minimum the 4 points are expected over here when you are talking about difference between drying and evaporation, just whatever I told you in previous session. So obviously the drying processes and equipment can be categorized according to the several criteria, including the nature or maybe the method of heat application or supply, and maybe the method of operation. And there are some factors such as maybe temperature of inlet and exhaust air, or maybe the volume of air or quantity of material, then period of drying or drying time, that also influences process of drying. And one more factor that affecting the drying process were about humidity. That point also we had seen in a previous session, along with some application or maybe some importance of drying in pharma industry, in context to pharma industry, isn't it? So till this particular point we had covered in a previous session, and mostly all part we have just revised now. And then today we are going to talk about also I think we have covered about some application or maybe mechanism of drying process as well, if I'm not wrong. So can anyone share about mechanism of drying process, what happened exactly? Mechanism of drying process, which are the two steps involved in mechanism of drying? Anyone?
So microwave, convection,
uh,
conduction, radiation.
yes, yes, that is somewhat what we can say. In case for example heat transfer, that are the ways that you are talking about, maybe the conduction, convection, radiation, isn't it? I'm just asking the first part of that general process of drying process. अगर आपको कोई चीज ड्राई करनी है, so what are the or what will be the exact mechanism, in what way that particular thing will get dry? एग्जाम्पल वी हैव पिक्ड अप, वॉशिंग मशीन है, कपड़े आप लोगों ने धोए हैं, आपको उसको ड्राई करना है, एज सिंपल एज इट इज। तो वो जो ड्राइंग होता है, so that is because of what process? Scientifically we will write.
So heat transfer, mass transfer.
Yes, Nikita, whatever two terminologies that we are using over here, that is the first thing is about heat transfer and another thing is about mass transfer. So students, whenever you are talking or studying pharmaceutical engineering, try to capture some key points under each topic or under each heading. So mechanism अगर पूछा है तो immediately two things should get pop up in your mind: heat and mass, heat transfer and mass transfer. If you know these terminologies, then you can write n number of things over here, that is what is heat transfer, then what is mass transfer, isn't it? And at the time you will complete this particular process, or maybe try will complete the complete answer of this particular question. For example, uh, give detailed mechanism of drying process. This will be the simple question. So obviously two things should pop up in your mind. One is about heat transfer and another thing is about mass transfer. And now you can explain that. For example, drying not only means the elimination of moisture, isn't it? But during the process, it is essential to preserve the physical structure and appearance as it is. And it is a complicated process. So obviously, drying involves the two processes. The first one that we have written is about heat transfer. So what it is exactly heat transfer? where heat is generated within the solid and flows to exterior surface, isn't it? So suppose I am just writing over here, the heat gets generated and flows towards the exterior surface. That is about heat transfer. And in case of mass transfer, suppose I am asking you, so you can say in mass transfer, which involves the movement of the moisture to the surface of the solid and its subsequent evaporation from the surface. So moisture that gets towards the surface and subsequent evaporation. So that is called as mass transfer. So this is as simple as it is about mechanism of drying process. And then you can quote example as well. Water, for example, water in a wet solid mass, either present in a bound form or maybe the unbound form. Are you agree with these things? Because suppose I am mentioning water we are using. So either this water will be in a bound or maybe unbound. And now you know the terminologies. What is the meaning of bound water and unbound water? Or unbound liquid content or unbound liquid content, because we have seen over here what is a bound water, what is a unbound water, where moisture content, where vapor pressure lower than the pure liquid, and here the vapor pressure is equal to the pure liquid. So these terminologies you know. So obviously you can correlate over here in case of mechanism of drying process that water in a wet solid mass either present in a bound form or in a unbound form, and moisture content of a substance that exerts equilibrium vapor pressure lower than that of the pure liquid at the same temperature is called as a bound water, and substances containing bound water are called as, what is the terminology? Suppose the substance contains bound water, what is the terminology we are using? Yes, do you remember students? That is hygroscopic. Whereas moisture content of a substance that exerts a equilibrium vapor pressure equal to that of the pure liquid at the same temperature is called as unbound water. So thus in a non-hygroscopic material all the liquid is in unbound form. So this is the non-hygroscopic material. Clear? We are talking about these two terminologies again, hygroscopic and non-hygroscopic. Hygroscopic bound part is there, so I just make it again red over here so that your understanding will be more on this. And unbound form, that is a non-hygroscopic. Clear this particular thing? So the moisture content is measured by a ratio of weight of water in a sample to the weight of dry sample. So that is called as a percentage moisture content. Suppose based on this, suppose I am asking you, what will is the percentage moisture content? What is the formula for this percentage moisture content? Yes, anyone can talk about this percentage moisture content as well. So that is weight of water in a sample. We can always write weight of water in sample divide by weight of dry sample into, as it is a percentage moisture content, into 100. So this is a simple formula of percentage moisture content. Weight of water in a sample divided by weight of dry sample into 100. Clear this particular point? Any doubt over here up to this? So can we move ahead to understand the drying curve or maybe to understand the equilibrium relationship as a new sub point, equilibrium relationship. Why we are talking about now, the question will not be there like on equilibrium relationship, but why we are talking this particular equilibrium relationship, so that your understanding will be better on this drying curve. What is a drying curve? Because question generally asked on this point about drying curve, and to get acquaintance with this drying curve, we are talking about equilibrium relationship first, and then we will touch this particular actual part of our syllabus, that is the drying curve. So if you allow me, I can go ahead on this new particular sub point as well. If your concepts related to basic terminologies are clear, then mechanism of drying process is clear, then we will talk about this equilibrium relationship. So dear students, equilibrium relationship is what? The moisture content of the solid when in a equilibrium with the given partial pressure of the vapor in the gas phase is called as the equilibrium moisture content that we have seen over here. This is equilibrium moisture content, isn't it? Because we are talking about this point now. And if solid contains more moisture than the EMC, then obviously the solid will commonly lose the water until EMC is reached. And this process is called as a desorption, as we have seen. And if solid contains less moisture than the EMC, then solid will continuously absorb the water until the EMC is reached. And this process is called as a sorption. So EMC, equilibrium moisture content of solid, is a constant for a given temperature of a humidity of a air. So for air of zero humidity, EMC of all material is 0. And obviously with the increase in air temperature, the EMC of solid gets decreased. So I am just mentioning key points over here again. EMC of solid is a constant, isn't it? Suppose I am mentioning point over here only. EMC of solid material is constant. Are you getting this point? The EMC of solid is a constant for a given temperature, isn't it? Suppose I am just writing small t as a point of temperature, and humidity of a air, whatever the relative humidity we are talking, or maybe the for example, I am just mentioning humidity. This is the temperature and this is the humidity. So we are talking about the equilibrium relationship. So equilibrium moisture content of a solid is a constant for a given temperature of a humidity of air. So for air of a zero humidity, EMC of all material is a 0. Equilibrium moisture content will be 0. And with increase in air temperature, the equilibrium moisture content of the solid get decreases. So in case of non-porous insoluble solid, just take an example of our powder, whatever Pond's powder we are using, or maybe any powder we are using. So you can just see the texture of the powder, that is a non-porous one. That is an insoluble powder. So that particular powder, the equilibrium moisture content is a 0. Are you getting this point? EMC of this tall powder is 0. For example, I am just mentioning over here as a tall. So equilibrium moisture content of this talc is 0. While in case of fibrous substances, EMC value is high. So EMC values for porous solids are much higher. We can conclude from these things. And the equilibrium moisture content of material that can be determined by putting a sample in a desiccator. Desiccator, you know desiccator, I think in 12th you use this desiccator. एक jar होता है और वो jar में we are generally keeping some compounds, maybe the calcium sulfate or calcium carbonate, which absorb the water content which we are storing in that particular jar. So such kind of the compound that we are using in a desiccator. So obviously the EMC of material that can be determined by putting a sample in a desiccator which are maintained at a known relative humidity, and the sample from each desiccator is collected and weighed at a particular interval until a constant weight is achieved. And so obviously the final moisture content is equilibrium moisture content. So the EMC data are useful in analysis of drying operations. तो जो भी डाटा हम लोगों को मिल रहा है फ्रॉम दिस स्टडी, सो दैट इज यूजफुल फॉर drying operation, whatever we are going to analyze or study, and particularly in predicting the final moisture content. By this, over drying can be the prevented. Then equilibrium relationships, we can now add one more point over here as a rate relationships, isn't it? So I just scroll down, we have one more rate relationship. So that we are, these two things that we are using to understand the drying curve. So students, in rate relationships, you know what happened? Drying of solids follow the two drying zones known as the constant rate period and the falling rate period. I am just mentioning over here. One is constant rate period and falling rate period. During the constant rate drying period, the moisture vaporized per unit time or per unit area of drying surface remains constant. So that is called as the constant rate period. Why? Because we are saying that during the constant rate drying period or constant rate drying period, the moisture vaporized per unit time per unit area of drying surface remains constant, and in falling rate drying period, the amount of moisture vaporized per unit time per unit area of drying surface decreases continuously. So that's why we are using this falling rate period. You getting this point? And the two zones are distinguished by a breakpoint that called the maybe critical moisture content. So that is called as a critical moisture content. Constant rate period and falling rate period. So here we are mentioning that particular point is called as critical moisture content, where the moisture content, what will be the definition then? Moisture content at which the constant rate drying period ends and the falling rate drying period starts. So typical drying rate curve you can observe over here. I have, I think, pasted over here drying curve. So this is a drying curve. See, this is a drying rate, for example, kilogram water per meter square per hour, and this is free moisture. So see, we are starting from this A, B, C, D and E. So this period we are talking, that is about the constant rate period in a rate relationship, and Another point is about falling rate from point number C. It will start the falling rate up to the point number E over here. So this constant rate to the falling rate, this particular point is called as a critical moisture content. So this is the first falling rate period and this is the second falling rate period. Are you getting this point? So this is useful to understand the mechanism of drying process, or maybe write a short note on drying curve by giving explanation of various terminologies. So what is the meaning of constant rate? What is the meaning of falling rate? Then first falling rate period is what? Second falling rate period is what? So all these terminologies you should know. So in this case, what is happening? Point B, what it represents? Suppose this is the point B. So what that particular point B represents? Equilibrium temperature conditions of the product surface. So the curve consists of section BC in this case. So this point number B to point number C, that is known as a constant rate periods represent. वो क्या शो करता है constant rate period? Removal of unbound water from the product. And the section CD represents first falling rate period. ये जो CD है, so that is the first falling rate period. वो क्या शो करता है? First falling rate period, which is also known as the period of unsaturated surface drying. And another section, that is DE in this case, D to E, that is called as a second falling rate period. So obviously, dear students, the first falling drying rate occurs when wetted spots in the surface continually decline until the surface of dried, that is the point D we are getting. And second falling rate, that is the period begins at a point D where the surface is completely dry, and the point C at which decrease in a drying rate start is referred to as the critical moisture content on this particular drying curve. Isn't it this? So clear the meaning? What is the meaning of constant rate? What is the meaning of falling rate? What is the meaning of first falling rate, second falling rate, and critical moisture content? So obviously you can mention the rate of drying from this, or maybe the loss on drying on this. Various terminologies we can mention over here. Clear this point? Any doubt over here to understand all these particular part or the segment as of now? Yes, terminologies we have seen, mechanism of drying process we have seen, then what is the meaning of water with bound, that is hygroscopic and non-hygroscopic, how will you calculate percentage moisture content, then what is the meaning of equilibrium relationship and rate relationship to understand the drying curve. And drying curve is nothing but the whatever the diagram we have depicted from the Subramanian book. So based on this you can easily write down a note on drying rate or maybe the drying curve. So students, any doubt over here as of now? Then we
No,
will
sir.
talk about, no, okay, all right. Then we will talk about next topic or the next heading of the same, that is about classification. classification of equipments, or maybe the classification of dryers. In classification of dryers, what is expected? So in classification of dryers, what we will do, these drying equipments are generally classified on the basis of their operating features. So जो भी operating features अगर रहेंगे, जो भी whatever the drying we are talking about operating features. Based on that, these drying equipments are classified. So obviously it can be classified as a batch or maybe the continuous. So in case of maybe batch dryer, I'm just writing here one word, maybe the batch or maybe as a continuous. So maybe in case of batch dryer में क्या होता है? The material is loaded in the drying equipment for a given period of time. So batch wise, हम लोग बोलते हैं ना batch wise. So maybe here the material is loaded, and against time we will just check the whether material is completely dry or not. So we can mention in case of batch dryer, the material is loaded in the drying equipment for a given period of time, and in case of continuous mode, the material is continuously added to the dryer. So here continuous addition is there. Right. तो all these dryers are classified based on their operating features. तो जैसे कि बैच ड्रायर होते हैं, तो वहाँ पे एक बार मटेरियल आपने 10 kg लोड किया, तो you will just check after 1 hour or maybe the 2 hour whether completely drying has happened or not. And in case of continuous क्या है, you can continuously load the material in a given device or maybe the given equipment continuously for the drying. So that is called as a continuous addition. So based on that, these drying equipments are classified. Also, in case of in few cases, vacuum also used to decrease the drying temperature, isn't it? So I am just mentioning one word over here, that is vacuum. Why vacuum is necessary? Yes, to decrease the drying temperature. So in some cases, not all, but in some cases, some dryers are using vacuum for decrease the drying temperatures. So students, we will just see the classification and then we will stop today over here. So in case of classification of dryer, the one we are using, that is about static bed dryer. This is the one class we can say, that is static bed dryer, isn't it? This is not double S, this is a single S. So static bed dryer is one class. An example, maybe suppose if we are considering, so example is there, maybe the tray dryer is there, or maybe freeze dryer is there, isn't it? Then one more class that we can use as a moving bed dryer. Moving, so I'm just mentioning over here, moving bed dryer. So moving bed dryer में कौन सी types है फिर? Can you add anything over here in moving bed dryer? Well-known example that we have to see is about drum dryer, isn't it? So this is a drum dryer. And third class is about fluidized bed dryer. Fluidized bed dryer. This is the third class of drying equipment that we are going to see over here. Then one more case is there, vacuum dryer is there, and maybe the pneumatic dryer also we can add over here. Vacuum dryer, and the last dryer is about pneumatic dryer, and well-known example of this pneumatic dryer is about spray dryer, isn't it? So maybe this is a classification. Suppose I'm just taking on a separate page all these dryer: static bed, moving bed, fluidized bed, and the vacuum dryer, and the pneumatic dryer. And this is PNEU, that is a pneumatic, or maybe the spray dryer. So dear students, we will talk on these dryers separately. Best, maybe we will talk about principle, then their construction, then their working, their advantages, disadvantages, pharmaceutical applications, then what we can say about their all these points that we will talk. For drum dryer, what is a synonym name for drum dryer? So for the drum dryer, there will be the synonym word that is called as a roller dryer as well. So this is content of our today's session, and I think we will stop over here now. Any doubt is there, you can just text or you can share question, or else we will stop now and see you tomorrow.